Okay, students, now we shall move on to the next concept, which is three address code. Very simple. I think you have heard of three address code already in program 5 in the lab. Okay, so I had also addressed about this in the class as well. Okay, so as the name itself says, three address code can have a maximum of three addresses. That is, it can have at most one operator. That is one or no operator. Okay, so look at this expression. It has two operators and three operands, right? So we have to break this into three address code. Since considering the precedence, star has more precedence over plus, I have written it this way. Y into z is stored in a temporary variable called as t1, and t1 is then added to x, and it is stored in another variable called as t2. So t1 and t2 are compiler generated temporary names. Okay, this is what is three address codes. You can have maximum of three addresses. That is, t1 is an address, y is an address, z is an address, and star that or into is an operator. Do not consider equal to as an operator. No, that is not considered as an operator here. Okay, so into is at most one operator here. Here also we have one operator. Okay, there are three ways of representing three address code. Okay, so the topic is representation of three address code. One is through quadruple, one is through triple way, and one is through indirect triple way. Quadruple way, as the name says, it is a quadruple. That means it has four fields, and the four fields are OP, argument 1, argument 2, and the result. That is why it is four field. I have taken an example here, which is a equal to b into minus c plus b into minus c. What you can see here is minus c, which is a unary operator. Okay, it's a unary operator. So minus c, so that will always be given first the precedence, unary operators. So we have written like this: minus c, which is stored in a temporary variable t1, then this one is multiplied with b, and it is stored in t2. Similarly, though it is going to repeat, but then we create it every time. Yeah, again we have another unary operator, so minus c, which is stored in t3. Again, this is also multiplied with b, so b into t3, which gives us t4. This one is added to this one, so the result of this one is stored in t2, the result of this one is stored in t4, right? So t2 and t4 are added, and then it is stored in a temporary variable t5. Later t5 is assigned to a, which is onto the left hand side. So if you have to represent this one, this is a three address code, guys. This is a three address code. As you can see here, let me take an example here. Here you have maximum of two addresses, right? Yeah, two addresses here. Okay, now operator. Okay, so what we shall do here is we shall write the sequence in the same way. Okay, so the first one is minus, since it is an unary operator. Okay, we have only one argument for it, so its argument is c. The second argument is there is nothing. Okay, it's nil. Yeah, and the result is stored in t1. This becomes a record 0. Okay, similarly the next one, which is star, its first operand is b, and the second one is t1, and it is stored in t2. Yeah, so in a similar way I shall complete it, or I shall show you the reference here. Okay, so this is how it looks like. See here, this is how it looks like. I think I better take this one only rather than writing and wasting time. Yeah, so look at this, guys. Star b t1 t2. Yeah, then for this minus, look at this, and look at the last expression here. T5 is so equal to is an operator over here, and then argument, it has only one argument, there is no argument over here, right? So t5, and the result is stored in a. Coming to triples, so triples has they have three fields. Okay, op, argument 1, and argument 2. They don't have the result field here. If you remember, fifth program is with respect to triple concept only. Okay, so let me take the same example here, and then it is written here, since it does not have a field for result, right? We will take the pointers of the records. Okay, so for example minus c, right, it is stored in record 0. Next, star takes b and minus c, right? So its first argument becomes b. What about the second argument? Second argument is stored in record c, so its reference, that is 0, is taken here. and it is stored in record 1. Minus C is stored in record 2. Again, star needs a B here, and then its minus C is stored in record 2 over here. That becomes record 3, and then what happens here? I have forgotten to take plus. Yeah, so plus will add, that is plus will add record 1 and record 3, right? So, and then equal to has look at this, A has an argument 1 and then fourth one. Okay, so this is how it is taken. Clear? Yeah, and remember here, we don't have a separate field called as result, and the rows here itself, we have pointers within the triples itself. That is, these are pointers, right? So we have pointers within the triple itself, but there is a disadvantage over here with respect to triples. Why? Because sometimes in the process of code optimization, we may have to move the instructions here and there. So when we start moving the instruction, guys, what happens is obviously the positions are going to change, right? And if the positions are going to change over here, that is going to affect over here also. They'll start referencing some other position. So that is one disadvantage in triple, though it saves one field, that is result field. But then if you start moving the instructions during optimization of a compiler, that is when these positions change, and it is going to affect. Okay, so that is one disadvantage of triple over here. Now let me talk about indirect triples over here. Indirect triples is similar to triples only, but there is one thing to overcome the disadvantage that I just mentioned now. Since we move the instructions during code optimization, what we will do is we will create a pointer which is going to point to the triple. Okay, so now look at this, guys. So this is the table, and this is one more pointer that we have created for indirect triples. Okay, so here one pointer 35 points to 0, 36 points to row 1, 37 points to row 2, 38 points to row 3. Okay, similarly here what happens is we are explicitly using one more pointer to point to the table here, but here we used the pointers within the list itself. Okay, so what happens here, even if you change the order of the instructions here, okay, this is going to change, right? But this is going to be the same, right? So here what happens is we can change, we can here you can change the way or the order of evaluation. For example, if you have to, when you change the instructions over here, you can change the order of evaluation. So changing the order of evaluation will be mentioned. Sometimes 35 will be pointing to 1, so 1 will be evaluated first, then 2 will be evaluated, and probably 4 will be evaluated, then probably 0 will be evaluated next. Okay, so this is the way you mention the evaluation order. This is going to be the same. This is the way you mention the evaluation order. So in that case, any moment in the instructions will not affect the position. So that is one advantage of indirect triple over direct triple. So you have these questions, you will obviously get this question in your externals. So the question will be how to represent three address codes. So you have three representations. One is quadruple way, one is a triple way, and one is indirect triple